Welcome to the first video cast of Chapter 4, Aqueous Reactions and Solution Stoichiometry. Make sure you have this handout in front of you before you watch the video cast so you can take notes as it goes along. First of all, what's in this chapter? In Chapter 4, we'll take a look at electrolytes, strong, weak, and non. These are things that dissolve in water, and if they're strong electrolytes, are good conductors of electricity. Good conductors of electricity. To be a conductor of electricity, you need to have positive or negatively charged ions, positively or negatively charged things, or electrons. And of course, ions are things that have a lack of or have gained electrons. Weak electrolytes are things that have only a little bit of positive negative charge, and non-electrolytes are things that, when dissolved in water, don't ionize at all and don't form positive or negatively charged things. We'll look at three types of reactions and identify the strong and weak electrolytes dissolved in there. And the three types of reactions we'll look at are called precipitation reactions. The second type are called acid-base reactions. And the third type are called oxidation-reduction type reactions. And we'll look closely in three separate video casts at each one of those types of reactions, identifying them and writing their reactions. And then lastly, we'll look at the mathematical nature of this chapter in two separate video casts. First of all, ways to express concentration and then therefore dilute aqueous solutions by adding water or something else to them. And then lastly, we'll look at stoichiometry in these solutions. So look at mass, volume, mass, those types of stoichiometry, except they'll all be in dissolved or aqueous type solutions, and we'll use this expression of concentration to do that. So, section 4.1, electrolytes. What are they? Electrolytes, as I indicated up above, are positive or negatively charged dissolved ions that conduct electricity. And this is why they're called electrolytes, is because they're good conductors of electricity. And as you'll see in a demonstration in class, we'll actually look at several different solutions, and we'll just use an apparatus that actually conducts electricity to light a light bulb. And we'll find out if it's a strong electrolyte, if it lights the light bulb really well. If it's weak, it'll only a little bit light the light bulb. If it's a non-electrolyte, it won't light the light bulb at all. And we could actually test the conductivity using a conductivity tester too, and actually get a numerical value as well. So electrolytes, what are they? What dissolved species are present in a solution of? And we have two examples right here. If we take KCN and we would dissolve that in water, we'd take this ionic substance and we'd break it up into K plus aqueous ions. This is an AQ, and we'd break it up into CN minus, and I put a little AQ down here, meaning dissolved ion. In NaClO4, we'd take that and we'd break it up into its ions as well. Na plus, put a little AQ down here, and ClO4 minus. Notice I didn't put it plus water anywhere in here, because all I'm doing is taking this solid and dissolving it in water. But to indicate that it's dissolved in water, I put AQ down below here to indicate that water is surrounding those ions. Now these would be strong electrolytes because they would be good conductors of electricity when they're dissolved in water. As a matter of fact, we'll find out in a little while that these salts are also soluble in water, which makes them strong electrolytes. That's the reason they are, is they're soluble and they break into their ions. So which solute will cause the light bulb in the experiment shown in figure 4.2 or the demonstration shown in class to glow more brightly? CH3OH or MgBr? And just so you have an idea, figure 4.2 in the textbook looks like this, and they have a little picture right here of a light bulb and some equipment with the wires hooked up to it, and then the light bulb of course glows dimly here and glows brightly here. This would be the strong electrolyte. If you look at the representation of the ions here, notice that there's lots of positively and negatively charged things. They don't show the water ions surrounding them, but you can see that there's lots of different ions. In here, in the weak electrolyte, where it's weakly lit, you can see there's some positive and negatively dissolved things. but not very many. Some of them are still stuck together. And then over here you can see that everything's molecular. It's all stuck together and there's no ions right there. This is on page 123 in your textbook if you want to take a little closer look at it. So anyway, which solute will cause the light bulb to glow more brightly? And they give us two example things right here. And I think at this time it'd be really good to just kind of make a quick table, and you might need a separate piece of paper for this, you can't figure it in here. But there's three classifications that we're kind of talking about in this area: strong, weak, and non-electrolytes. Strong, weak, and non. And there's actually three classifications of things that fit into strongs that we're going to talk about in this chapter. Those are salts that dissolve in water, and we'll talk about which ones actually dissolve in a little while. We'll give some rules for that. So salts that dissolve in water, and a salt, if you don't remember from chapter 2, is a positively charged metal or polyatomic ion stuck together with a negative non-metal, or is known as an anion as well, or it could be a polyatomic ion. And that's the definition of a salt, is a metal and a nonmetal, or a metal and a polyatomic ion, or two polyatomic ions, the same as what is sometimes known as an ionically bonded things. Now it has to be a dissolvable one, so it has to be a soluble salt. The second strong electrolyte, one that would conduct electricity really good, are things called strong acids. Strong acids are molecular, but they dissolve in water and they completely dissociate. We'll learn 7 strong acids during this chapter. And then the third type of thing that is a strong electrolyte is a strong base. Strong base. And we'll learn a little bit about the difference between acids and bases in this chapter, and a lot more in chapter 16. So those are the three classifications of what are called strong electrolytes, good conductors of electricity. Secondly, we'll take a look at what are weak electrolytes. Well, weak electrolytes are weak acids and weak bases. And as I alluded to before, we'll memorize 7 strong acids in this chapter, and those are the only 7 that you'll pretty much encounter the entire class, and we'll memorize 8 strong bases. And then anything else that is considered to be an acid or a base will be weak. And so it's kind of a process of elimination that you know what the weak acids and weak bases are, because they're anything else except the things that you memorize. The non-electrolytes are all molecular things. Molecular things. Molecular. Molecular things are 2 nonmetals, 2 or more nonmetals that are stuck together that may dissolve, but they don't dissociate or break into their ions as well. And the way you kind of know which these non-electrolytes are and these weak electrolytes are is by a process of elimination. You're going to memorize what the strong dissolvable ionic salts are. You're going to memorize 7 strong acids. You're going to memorize 8 strong bases. Anything else is going to fit into this category over here. Fit into this category over here. So this question is a little bit premature because it says, which solute will cause a light bulb in the experiment demonstration to glow more brightly? And they give us 2 choices. CH3OH is actually known as methanol, and if you notice, CH3OH contains only nonmetals. And if you look at this little chart that we made right here, molecular things contain 2 or more nonmetals. And it turns out that methanol is one of those things that's a non-conductor of electricity because it doesn't dissociate or break into its ions in a solution. Whereas MgBr2, these are a metal and a nonmetal, and that'll break up really well because it happens to be soluble into Mg+2 and 2Br-. And in the second video cast of this chapter, we'll look at what salts actually do dissolve, and we'll give you some general rules. So what's the difference between strong, weak, and non-electrolytes? Because that's the whole focus of this first video cast. What's the difference? Well, as I alluded to before, strong electrolytes are things that give you positive and negatively charged ions in solution. They give you cations and anions in solution. And like I said, you can get them from 3 different places. You can get them from soluble salts, you can get them from strong acids, and you can get them from strong bases. And as I said before, there's 7 strong acids, 8 strong bases, and there's a whole mess of soluble salts that we'll learn about. Anything else is either a weak or non-electrolyte. It doesn't dissolve real well, or it dissolves real well but doesn't break up into positive or negatively charged things. And knowing this difference between strong, weak, and non, this is actually the difference you want to know. Strong and weak and non. You can group these 2 together, actually, weak and non. Knowing that difference is key to to just about everything else we do in the entire class. If you can identify between the difference between those and do some process of elimination, you will help yourself a ton. So there are three kinds of strong electrolytes we'll learn about in this chapter. What are they? And I told you before, these are soluble salts, they are strong acids, and they are strong bases. And we'll get a little bit more into those in section 2 right away. So next video cast, we'll take a look at section 4.2 in your chapter, where it talks about a particular type of reaction. I said we'd look at 3 different types of reactions in depth. And the first one we're going to talk about are precipitation reactions. Precipitation reactions are ones where we take salts and we find out whether they're soluble or not. So, just to summarize, once again, strong, weak, and non-electrolytes. Strong electrolytes contain are a group of substances that are made up of 3 things: ionic, soluble salts, strong acids, strong bases. Everything else is weak or non. Weak or non. And watch close in the next 2 video casts, because we'll introduce you to all of the strong electrolytes, and then we'll also introduce you to everything else by process of elimination. Good luck with your strong and weak electrolytes.